Hello everyone, my name is Neha Thakur. Today I am going to discuss about Cmos fabrication. So Cmos is what it is, complementary MOSFET. So before this video, if you have not watched my Nmos fabrication video, so you can go through it once so that you will understand this one much better. So here are few points to remember before moving on to the video. That is, for when NMOS transistor was fabricated, at that time the substrate type used was P type and impurities diffused are N plus. For PMOS fabrication, only the difference will be in the substrate type it will be N type and impurities will be P plus. For CMOS fabrication, two types of most general processes are N-well and P-well. So N-well actually is what it is, the external diffused area in the substrate, and the nature of well and substrates are opposite in nature. So suppose if N-well is being used for CMOS fabrication, then the substrate type will be P plus, it will be P type, and in substrate, if it is for N-well, if suppose it is of N type, then impurities will be P type, and if substrate is of P type, then impurities will be N plus, and for P-well process, the substrate type will be N type, and if substrate is N type, then the impurity diffused will be of P plus, and if well is P type, then impurities diffused will be N plus. So actually, what is a well? Suppose you have a big substrate, you can imagine it in the form of a river, you can say. So suppose this is your substrate containing lot of water, okay, and then what is a well? A well will be if you suppose dope some external pond or external bucket of water into it. Let us say it is a big bathtub, and in that you pour some, externally you dip some bucket inside the bathtub, then it will become well. So well is basically externally diffused area into the substrate, and what is the condition? That is, substrate is of N type, then the well should be of P type. See, because if both are same, then there will be no difference. You can say in a bucket of general water you have doped some Bisleri water, so obviously their indexes will be same, so they cannot get mixed up easily. So similarly, it is the concept of well that comes into the CMOS. Now why this concept of well is required in CMOS? See, because till now the transistors you have fabricated must be either only NMOS or PMOS. Okay, so for NMOS P-type substrate is required, for PMOS N-type substrate is required, but CMOS is the combination of NMOS plus PMOS. That means the substrates required will be of both type. So which one should be used as a substrate? It is the big fight between NMOS and PMOS. So to resolve this issue, the wells are fabricated. So today in this video I am going to discuss about P-well process. If you understood this P-well process, then N-well process also you will be able to implement. So for P-well process, as I told you, the nature of well and substrate should be opposite. That means if P-well is there, that means you should start with the substrate that is of N type. Then N-type substrate, into the N-type substrate a P-well is doped inside it. So what is a well? A well is your, again it is the externally diffused area, or it is the externally diffused, you can say, material into the base substrate. Then later on other steps will remain same as in the earlier video you have seen. The thick SiO2 layer is used for making source and drain region. So then again a thick SiO2 layer is deposited all over the surface, and because it is required only on the source and drain region, so it will remain only till this portion. Now see, if you see this CMOS diagram, so what is there? Source, and both the sources are opposite to each other. One is connected to VDD, one is connected to ground, and both the drains are shorted together. In between there is gate. So that means here this is the source of PMOS. See, because N type substrate is there, so PMOS will be fabricated here, and P-type well, it is acting as a substrate for NMOS transistor. So this will be the source for it, and these are the two common drain regions for both NMOS and PMOS. Then for gate terminal, a thin oxide layer and a polysilicon layer is used for implementation. So again a thin layer of oxide and a polysilicon layer. Polysilicon is layer nothing but polycrystalline silicon layer. It is deposited over it, and it will be present only on the gate terminal. Then later on, P-type diffusion is done for PMOS, and NMOS area is masked. So see, as after the till now what is happening, the source, gate and drain region of both NMOS and PMOS are defined. So once the source, gate and drain regions are defined, after that the impurities have to be doped. So for impurities doping, so for making the PMOS, only P plus impurities will be required. So P plus will be doped in the N type substrate, because in N type substrate PMOS will be implemented. So P plus impurities are doped in the N type substrate, and these are doped by using self aligned process. Self-aligned process is the process which is used while doping the impurities, because the space or the window between the terminals is very small, so you cannot adjust the impurities actually. So there is self-aligned process. These impurities, they get aligned by that process, and as P plus impurities are only required for fabricating PMOS, not for the NMOS, hence this N region, it is getting masked. Masked means what? When all the impurities are being spreaded over the surface, then this region gets protected from it, and no impurity falls in this region. So the P plus mask positive is used. P plus mask positive means it is masking the region from positive impurities, or P-type diffusion. In the next N-type diffusion is done. So N-type diffusion, while it is being done, N-type diffusion will be done for the NMOS transistor. At that time this PMOS region, it is getting masked. So it will be masked so that no impurities will fall upon this region. They all keep on falling upon this region. And later on, contact cuts are made for substrate connection. So this is one new thing. So as you can see in the figure here, this is last terminal is the body terminal. So this body terminal of the NMOS, it is connected to the ground, and the body terminal of the PMOS is connected to the VDD. So this basically body terminal is what? It is the substrate type terminal. So here you can see for the PMOS, the substrate type is N substrate. So here the body terminal is made as N plus, and for NMOS, if you see, the substrate is of P type, P well, so the P plus will be made as the body terminal, and they both are connected to ground. And here body terminal and sources both are shorted to VDD, and this is showing the V out, that is the both drains, and both the gates are connected to the input. So this is basically the complete fabrication step for CMOS fabrication for using P-well process. If anyhow you get in exams, or if you want to make the N-well process, so what will be the difference for N-well process? For N-well process, I told you, if N-well process is there, you will start with P-type substrate, and in CMOS first here comes PMOS and then the NMOS, and N-well means you will fabricate PMOS inside it. So it is a good idea that you make N-well on the left hand side, okay, because ideally your PMOS should come first, then NMOS. So in P-type substrate you will be fabricating N-type transistor, and in N-well you have to fabricate P-type transistor. In the second step, what will happen? Then again a thick layer of SiO2 layer will be deposited all over the substrate. So this is your P-type substrate, and N-well. So a thick layer of SiO2 will be deposited all over the surface, but because thick oxide is required only for the source and drain region, so we will use directly make this. This is suppose source, and these are the drains region, and this is again source of NMOS, and this is your N-well. Later on a thin oxide and polysilicon layer will be deposited. So this is your P-type substrate into which N-well is deposited. This is N-type. Then again a thick SiO2 layer is deposited. So after this step, what will come? A thin oxide layer will be used for making the gate terminal and the polysilicon. So a thin oxide and a polysilicon layer will be used for making it, and then later on, now you see, once the source, gate and drain they are over, so you will start diffusing the impurities. So for impurities diffusion, this is P, this is N plus, and this is your sources, and here thin oxide and polysilicon layer. And now later on the impurities have to be doped. So suppose in N plus you have to implement PMOS. Let us say P plus impurities are doped here. So this is P plus and this is P plus. P plus impurities, meanwhile this region will be masked, and later on when N plus has to be doped, here N plus and N plus, so at that time this region will be masked and this region will not be masked. So here it will be N plus and N plus. So after these dopings are over, then contact cuts have to be made. Contact cuts means substrate connection. So here N plus N is the substrate connection. So here it will be N plus. So basically this is P type, this is N, and then source, drain, source, it will be gate terminal, so till now these dopings are done. Now the substrate connection is remaining, so N type, then that means this will be N plus, little highly doped, and if this is P type substrate, then it will be P plus, and then the connection will be done. So your PMOS, it will be connected to VDD. So this source and substrate, these source and substrate, they will be connected to VDD, and here the source and substrate, they will be connected to the ground. So here this is your N-well process. Initially I have discussed P-well process. So one another process is also there for Cmos fabrication. It is known as twin tub. So what is twin tub? Basically in twin tub both the types of wells are there. Twin tub means two tubs are there. So in this process one P well and another N well is there in the substrate. When the substrate is not defined, then at that time both twin tubs N type and P type, both substrates are present for fabrication. So this is how you can do the Cmos fabrication. If you have any doubt, you can ask me in the comment section, and please like, share and subscribe. Thank you.